For as long as we've had secrets, we've had codes to protect them. And for as long as we've had codes, there have been people dying to break them. So let's dive into this incredible, timeless battle of wits, from ancient mysteries all the way to the future of our digital world.
And it all starts right here, with what might just be the greatest cryptographic puzzle ever. It's called the Voynich Manuscript. And inside, it's filled with a language that nobody recognizes, pictures of planets that don't seem to exist, and star charts that don't match our sky.
For hundreds of years, the smartest people have thrown themselves at this thing and come up with nothing. But to really get why this book is such a fortress, we first need to understand how fortresses like it are supposed to fall. Now, this isn't just some forgotten artifact. We know it from the early 1400s. We know it's written in this strange script people just call Voynichese. But here's the real kicker. The best American and British codebreakers from World War II, the geniuses at Bletchley Park who cracked the Nazis' Enigma code, they took a shot at this. And they failed. Completely. That's when you know you're not just looking at a code. You're looking at a true mystery.
So, how do you read the unreadable? Well, there's a whole art and science to it, and it's called cryptanalysis.
At its heart, cryptanalysis is really just the art of finding a weakness. It's all about taking a bunch of gibberish, what we call ciphertext, and turning it back into a readable message, all without having the secret key. And let me tell you, this has been an arms race for centuries. It goes way back to the 9th century when the polymath Al-Kindi literally wrote the book on how to do this. It's the reason Mary Queen of Scots lost her head. They cracked her secret letters. And it just kept escalating, all the way to World War II, where early computers were built just to break so-called unbreakable codes. And that first major weapon in the codebreaker's arsenal wasn't a computer at all. It was a simple but brilliant observation about language itself, first written down by that same scholar, Al-Kindi. So here's how it works, and it's pretty clever. In any language, some letters just show up more than others. In English, E is the absolute champion. So, you look at a coded message, you count up all the symbols, and you see which one appears the most often. Chances are that symbol is E. You swap it in, and then you look for common pairs, like TH. Suddenly, little pieces of words start to appear. It's kind of like playing Sudoku, but with letters. But what happens when the codes get way, way more complicated? Well, that brings us to maybe the most high-stakes code-breaking duel in all of human history, cracking the German Enigma machine. And you just can't overstate how important this was. General Dwight D. Eisenhower himself said the intelligence they got from cracking these codes, what they called Ultra, was decisive in winning World War II. It's believed to have shortened the war by years, saving millions of lives. The Enigma machine was an absolute monster. It was this incredible electromechanical device. With all its rotors and wires, it created a new cipher for every single letter you typed, so the letter E might be X one moment, and then a P the next. It totally wiped out the patterns that frequency analysis depends on. It really did seem invincible. But it wasn't, and the way they broke it is fascinating. It wasn't about some single brilliant mathematical insight. Nope. It was about exploiting good old-fashioned human error. The folks at Bletchley Park realized the machine was strong, but the people using it, well, they took shortcuts. They'd get lazy, or they'd include predictable phrases in their messages, like weather report or Heil Hitler. The codebreakers attacked the weakest link in the chain, the people. Okay, so the story of Enigma proves that even the most complex systems can have a flaw. But that kind of begs the question, right? What if you could build a system that had no flaws? Is it even possible to create a code that is truly, provably 100% unbreakable, no matter how smart you are or how powerful your computer is? Well, the answer is yes. It actually exists. It's called the one-time pad. Back in the 1940s, the genius Claude Shannon proved that this method provides something called perfect secrecy. That means when it's done right, the encrypted message gives a codebreaker absolutely zero new information about the original text. Nothing. Nada. But that phrase, when it's done right, is doing a lot of heavy lifting. For the one-time pad to work, you have to follow 4 unbreakable rules. The key has to be totally random. It has to be just as long as your message. It can never, ever be used more than once. And of course, it has to be kept completely secret. You break even one of those rules, just a little bit, and the whole thing falls apart. So if we've had the secret to perfectly secure communication since the 1940s, why isn't everyone using it for everything? What's the catch? The catch is all about logistics. Just think about it for a second. If you want to send me a 10-page secure document, you first have to find a way to securely give me a 10-page, totally random, unique key. And then for the next document, you got to do it all over again with a brand new key. It's just a nightmare. It's not practical for the amount we communicate today.
And history gives us the perfect, brutal example of theory crashing into reality. During the Cold War, the US managed to break into top-secret Soviet spy messages in a project called Venona. How? The Soviets were using one-time pads. But under the stress of war, their code clerks broke rule number 3. They reused some of the keys. That one mistake was all it took to tear a hole in their perfect system and expose a massive spy ring.
And that brings us to today. I mean, our entire world, our banking, our conversations, everything, it's all built on a foundation of encryption. So where does this cat and mouse game stand now?
So is cryptanalysis dead? Oh, far from it. Not even close. The game has just changed. The playing field looks totally different now.
See, instead of attacking the math head-on, which is really, really hard, attackers now look for other weaknesses. They'll analyze things like the tiny fluctuations in a computer's power usage or the exact amount of time it takes to do a calculation to find clues. They hunt for simple bugs in the software. And then there's the big one, lurking on the horizon: quantum computing. The fear is that a powerful quantum computer could one day break most of the encryption that protects the entire internet. So it's pretty clear that this epic struggle, from Al-Kindi with his pen and paper to Alan Turing and his machines, all the way to the quantum physicist of tomorrow, it has never stopped. The codes just get stronger, and the code breakers just get more clever. Which really leaves us with this one final, fascinating thought. We know, theoretically, how to create a perfect, uncrackable code. So why is it that in our modern world, a world built on data, it feels like our information is more vulnerable than it has ever been in human history?